Now let us begin with our next topic, heat, internal energy and work. Now earlier in this chapter we have already seen about the transfer of heat, which is from one point to another, but that point is what? It is from higher temperature to lower temperature. As shown in the diagram, you can understand how the heat is being transferred from one object to another. That is, if there are two substances with different temperatures and these two substances are brought in contact with each other, then the substance at higher temperature loses its heat and the substance with the lower temperature gains the heat. That means the high temperature object will transfer its heat to the lower temperature object. So here there is a transfer of heat and one of the object will, yes, obviously lose its energy and one of the object will gain its energy. But who will gain and who will lose its energy, that is heat energy? It is the object which is having high temperature will lose its heat and the object with low temperature will gain the heat. Now the question arises that why the engine gets warmer or heated when it is running, and when you are rubbing your palms together it generates warmth, right? Why this is happening? So this two examples or many examples like this will be explained on the basis of, yes, concepts of internal energy of the system and conversion of work and heat into each other, that is work into heat or heat into work, vice versa, and the laws which are governing these conversions. So let us see internal energy. A system consists of large number of molecules, or we can say atoms. So what is internal energy? Internal energy is the energy associated with random disordered motion of molecules of a system. So here the internal energy in this chapter will be denoted by capital U. Now let us see more about internal energy. Internal energy consists of kinetic energy and potential energy. Kinetic energy and potential energy can be indicated by what? Okay, let us see how kinetic energy is being indicated or recognized in a system. So when there is a rise in temperature, then that means what? The kinetic energy is being present over there, or we can say indicate this kinetic energy is indicated by rise in temperature. Then due to this there is increase in vibration of molecule. Vibration of molecules, that means what? Motion of the atoms and molecule of the system will increase due to the rising temperature. Now potential energy. How potential energy can be indicated? It can be indicated by change in state. Change in state means what? There are three types of states we are knowing, right? So it is what? Liquid, gaseous state and solid state. If solid is going to change into liquid, then that is nothing but what? That means what? That system is having what? Potential energy, or change in potential energy is there, or we can say that the potential energy is indicated by the change in state. Now due to this there is increase in the distance between two molecules. That means what? Before giving a temperature to any system, the two molecules having a fixed distance, or we can say they are having an average distance between them. Any system will have average distance between the two molecules. Now if the temperature rises and there is a change in state, then what will happen? There is an increase in distance between two molecules. Now let us see for an ideal monoatomic gas. That means before learning about this, I want to tell you that we are now going to study about the microscopic order of energy of a moving object. That means what? For an ideal monoatomic gas. Since we have seen this part in kinetic theory of gases, so from that only we will take a reference. That is, for an ideal monoatomic gas, internal energy is just the transitional kinetic energy of atoms having motion. So for monoatomic gas, we are considering only the transitional motion. Now for polyatomic gases, it has rotational as well as it has vibrational kinetic energy of atom in addition to the transitional kinetic energy. That means what? The polyatomic gases are having transitional plus vibrational and rotational motion. So this is again at molecular level, that is microscopic scale only. Thermodynamic system. Thermodynamic system is a collection, or you can say a group of objects that can form a unit which may have ability to exchange energy with the surrounding. For example, we can say a glass of water. A whole glass of water is whole thing is called as what? System. Now what is environment? Why we are studying about these parts? Because we have to play with these parts, that is environment, surrounding, then system, then what is the boundary. These things you should know before studying this chapter ahead. Okay. Now what is surrounding? Surrounding is nothing but environment. Now which environment? It is nothing but what? Anything that is not the part of system is its surrounding or environment. That means what? A glass of water is placed on the table, right? And the atmosphere around the glass of water is called as what? Is surrounding, or you can say environment. Now what is glass? Glass is nothing but it is the boundary between the system and the surrounding. So here in the diagram you can say that the system is been surrounded by a boundary, system boundary we can say it, and the other thing which is not the part of the system is called as what? Yes, surrounding. Now this thermodynamic system can be classified on the basis of possible transfer of heat. Since we know that there is a transfer of heat, but during this transfer of heat it may happen that matter is also transferred to the environment, or the matter from the environment is transferred to the system. It may happen like that. So on the basis of this transfer of heat and matter to the environment, we can classify thermodynamic system. So thermodynamic system is classified into three types, that is closed system, open system and isolated system. Now what is mean by open system? Open system, in the word itself it is having its meaning. That is, open system can exchange both matter as well as energy with the environment. Now let us take an example of this open system. If a glass has been, if a vessel or a container which is having water in it, it is kept on a burner, and if the burner is on, then what will happen? The water starts boiling and it is converted into vapors, or you can say steam. This steam is being transferred to the environment directly. That is, the water molecule are converted into gas molecule, and these gas molecule are then transferred to the environment. That is, there is a transfer of heat also, and there is a transfer of matter also. Okay. Now here in the open system, the example we have given that water, boiling water, right? On that we are not going to keep any lid or cover. We are not going to cover it. Since in the diagram itself you can see that the test tube over there is having some liquid in it, and it is not been covered by any lid. In the second diagram itself below, the square box is nothing but a system, and the purple color line are nothing but the matter which is being transferred to the surrounding. Even there is a transfer of energy. Now see the closed system. Closed system means what? If you are let us see the definition of it. Closed system is nothing but it can exchange the energy, but it cannot transfer the matter with the environment. That is, in the diagram you can see that the test tube is now covered with a rubber tube, right, or rubber lid. Now In the second diagram, that is below this, there is a square box, right? So in this, the matter is not been transferred to the surrounding, but there is a conversion of liquid into gaseous state. So for example, a water is boiling, and if you keep a lid on it, then what will happen? The water is converted into steam, and this steam is condensed on the walls of the container and the lid of the container, right? So this is nothing but what? There is a change in state, but yes, there is a transfer of energy also, or you can say there is a transfer of heat to the environment, but yes, there is no transfer of matter with the environment. Isolated system. Isolated system can exchange neither energy nor the matter with the environment. That is, whole system is being closed or evacuated in a different insulating material. For example, I can tell you that thermos, right? Nowadays we are using the thermos for storing the hot water, or you can say hot soup, right? So from that you can see that the hotness of that soup or any liquid which is in the thermos remains as it is. That means what? There is no transfer of heat towards the surrounding or towards the energy. So in the diagram you can see that the matter and the energy is not being transferred to the environment. It is all evacuated in a whole, yes, insulation. So this is all about open system, closed system and isolated system. Now, thermodynamic process. Thermodynamic process is a process in which the thermodynamic state is being changed. For example, as now we have already seen about the example boiling water. So, boiling water in a vessel with a lid. So, what will happen? The water starts boiling, steam is also being produced, and this steam exerts pressure. So, this steam exerts pressure on wall of the vessels, even on the lid. So this is all about the change in state, and this change in state is nothing but called as what? Thermodynamic. Now the state of the water in the vessel is changed. Why this is changed? Because the temperature, the volume and the pressure of the water inside the vessel has been changed when the water starts boiling. Now I think you have understood all about thermodynamic system and thermodynamic process. Thank you.